All right, so this is part B, second part of this lesson, but it's really different than the first part of the lesson, really different. Even though, so the lesson, I think, what was the lesson, or the name of this actual lesson was like classifying quadrilaterals, is that what it's called? Yeah. And this is called the quadrilateral angle sum theorem, but then we're going to do, actually, you know what? I'm going to change that. Is that all right? Because we're not just doing quadrilaterals in this lesson. They call this the convex polygon. Okay. Because this fits under a quadrilateral as well, okay? Because a quadrilateral would be considered that. Let me change my writing thing here, and then we'll be ready to go. All right, we're good to go. All right, so let's talk about the quadrilateral first. So let's just do a rectangle. Would you agree that's quadrilateral? Okay, I'll tell you what, before I do that, I'll just draw it by hand. I just want to refer to something that we've talked about before, then we'll do the quadrilateral, okay? What if I asked you, that's angle 1, that's angle 2, that's angle 3. What if I asked you to add up all three of those angles? What would they add up to be? 180. And we've talked about that before, haven't we? Yes, we have. Okay. So angle 1 plus angle 2 plus angle 3 equals 180 degrees. Doesn't matter what kind of a triangle that I have. Okay, that looks like an acute triangle. I could have a right triangle. I can have an obtuse triangle. All three angles will always, no matter how big the triangle is, how small it is, no matter what the shape of it is, it doesn't matter. Every single triangle in the world that you could ever imagine, all the angles add up to what? 180 degrees. Okay, so that's the angle what? Sum. What does the sum mean when you talk about math? S-U-M. Addition, not just addition, but what? The answer to an addition problem, okay? So when you add up these, this is a sum. Why? Because you're adding, all right? That's what Io said, adding, all right? So sum means adding. So what are we going to do? Here's the angle sum of a triangle. Angle sum of a triangle is equal to what? 180 degrees. I should put triangle right here. Triangle. All right. So what do you think the angle sum of a quadrilateral, a four-sided figure is? Now, if this is a rectangle, it's pretty easy to figure out what the angle sum is. So if this is a rectangle, what's true about all four of these angles? Okay, they're all 90 degrees. It's true they're all the same, but more specifically, they're all 90 degrees. Agreed? All right. What if I asked you the angle sum of a rectangle? What am I asking you to do? You got it. Okay, add them up. Right, add them up. 90 and 90 is 180, and this 90 and 90 is what? 180. So you add 180 and 180, what do you get? You get 360 degrees. You could do that as well. You're right. There's 90, there's four of them. 90 times 4, 9 times 4 is 36, right? Stick a 0 on the end because it's 90, 360. Would you agree? What about a square? Same thing. What about any quadrilateral? Now, not every single one has right angles in it, though, does it? Okay, but watch this. I'm going to draw. What is your guess, though? If a rectangle, you add up all the angles, it's 90. On a square, you add up all the angles, it's a 90. What's your guess? Just a guess on what do you think if you add up all four angles of any four-sided figure? What do you think it should be? Probably 360. That's a good answer. I like that. Probably 360. All right? Let me show you why. And that's true. Okay? Every quadrilateral, no matter what shape, no matter how big, if it's a quadrilateral, if there's four sides, and it's a polygon, they all come together, right, at points, 4 points. If you add up all four angles, it's going to be 360. Let me show you why. So I'm just going to draw some random quadrilateral. Okay, nothing. It's going to just be kind of weird looking. And it kind of looks like a trapezoid. Let's make it not look like a trapezoid. All right, because I just want to draw a random quadrilateral. That's all I want. Okay, I don't want anything specific. So that's not a parallelogram. It's not a trapezoid. It's not a kite. It's just a four-sided figure, which is a what? What's any general four-sided figure called? It's quadrilateral, exactly. So watch what I'm going to do here. This is where I think it gets kind of interesting. It's the beginning, okay, of what I think is interesting. And what we're going to do is we're going to do this. Remember how I changed the name of it from quadrilateral angle sum to convex polygon angle sum? I'll show you why. So watch this. If I did this, if I drew a diagonal, we've talked about diagonals, right, from one corner to another. I've broken that quadrilateral into two what? Two triangles. So you got that one triangle right there. Everybody see that? And then you got this triangle right there. Now let's think about this. What am I trying to do? I'm trying to add up all the angles, aren't I? All right, angle sum. That's what this whole lesson's about. Finding the angle sum, the sum of the angles. If I add up all the angles, that's what I'm trying to find. So triangle, we'll call it triangle 1. Okay, what's the sum of all the angles in triangle 1? 180 degrees. Do you agree? So this angle, this one, and this one, all three add up to 180 degrees. You see where I'm going with this? What am I going to do now? Angle 2, what are the sum of all the angles of angle 2? 180 degrees. Agreed? So if this triangle's got 180 and this triangle's got 180, what does the whole entire quadrilateral have? Not 180, 360, right? Because what do you do to those? You add them up and you get 360. And again, it doesn't matter what shape it is. As long as you got four sides, it's a quadrilateral. As long as you got four sides, when I add up all the angles of this triangle and all the angles of this triangle, that means that's all the angles of this quadrilateral. Do you see that? So all four of these. Now they're not equal. I put one arc for each of them. That doesn't mean they're equal. I'm just trying to mark the angles, okay? But all four of these angles add up to what? 360. So what's the angle sum of any quadrilateral? 360, okay? It's 360. You got it? All right. Let's do another shape. I'm going to do a couple more, and then we're going to see a pattern. I want you to see the pattern. And then what we're going to do is we're going to come up with a little formula, okay, kind of on our own. We're going to come up with a formula, and we're going to be able to find the angle sum of any polygon. When I mean any, I mean any. So it could be, I'm going to do a, what's after 4? 5, what do we call a five-sided? A pentagon, right. Now again, it doesn't have to be like a perfect pentagon. It can be any pentagon, all right? So, oops, let's change this back to white. So there's 1, there's 2, there's 3. How many do I need? 4 and 5. All right? Again, it's nothing special. I didn't make all the sides equal to each other or anything like that. It's just a basic, normal, everyday, five-sided figure, okay? What I'm going to do is this. Do you remember how I did the diagonal? I took one point and I drew to an opposite angle. Do you see that? Could I draw any other diagonals from this particular point? I went from here to here. What about from there to there? Would that be considered a diagonal? No, because it lies right on the polygon itself, okay? Could I go from here to here? No, that's not considered diagonal. So how many diagonals can I draw with a four-sided figure? Just the one. Well, from this point, just from this point, just one, correct? I could draw a diagonal from this point to this point, but from that one particular point, I can only draw one diagonal. Keep that in mind. What I'm going to do is here, pick a point. It doesn't matter. I don't care what point you pick. Bottom left, this one? Okay. So we're going to use this one right here. How many diagonals can I draw from that one particular point? I could draw 5. Well, is that a diagonal? No, because it goes right along the polygon, okay? Where can I go? From here where? to this top one, okay? And then I can go from here to where? To there. Can I draw any more? No. All right? So I want you to see something. I'll write this down. Well, you know what I should have done? I should have done this up here. Let me do this. I'm trying to get everything straight here. Let's do it right here. So how many sides? I got 4 sides, correct? How many triangles did I make? I drew that one diagonal, correct? How many triangles did I make with 4 sides? 2 triangles. This is where I'm going to see a pattern. You with me on this? And then, so how'd you find all the angles? You went 2 times what? One triangle has how many degrees? 180, but you had 2 triangles, so what is that? That's 360. Agreed? All right, you're going to see pretty soon here, you're going to see a pattern developing. 4 sides, 2 triangles, 360. Got it? Let's do this one. What do we have here? 5 what? 5 sides. How many triangles did I make? 1, 2, what? 3. So I made 3 triangles. So how am I going to find the angle sum? I keep saying that, but I'm going to repeat what it means. What does it mean to find the angle sum? You add up all the angles. That's right. So if I wanted to add up this one, this one, this one, this one, this one, all 5 angles, what do they add up to be? All right. Well, I made 3 triangles out of it. So how do I find what all the angles add up to be? 3 times what? 180. Okay. Each triangle. This has 180 degrees in it, right? Agreed? This has 180 degrees in it. And what? This one's got 180 degrees in it. So how do I find what all the angles add up to be? 1, 2, 3. 3 times 180. What is that? 540, isn't it? I should have this memorized. I teach this enough. I think it's 540. I'm just going to put it in my calculator just to make sure. It is 540, okay? So that would be 540 degrees. What does that mean? What does that 540 mean? I need you to understand what these numbers are representing. That means if I took this angle and did what? Add it to this one, to this one, to this one, to this one, what do all 5 of those angles add up to be? 540 degrees. Does that mean each of the angles is 540 degrees? No, not at all. But they all add up to be 540 degrees. Let's do one more, and hopefully we're going to see a pattern. What I want you to look at is this. When we had 4 sides, how many triangles did we have? 2. When we had 5 sides, we had 3 triangles. How many triangles do you think we're going to have if I have a 6-sided figure? Good. Now you're seeing the pattern, aren't you? All right. I'm going to draw it. This is the last one I'm going to draw, but I just want us to see the pattern. So a 6-sided figure. Again, it can be just any random 6-sided figure. All right. There's 1. There's 2. There's 3. There's 4. There's 5. And then there's 6. Okay. Nothing special about it. Again, very random 6-sided figure, which is called a what, by the way? No, 6? Hexagon. Hexagon. That's right. Okay. Now, what was my first step? Draw a what? Not just triangles. How did I draw the triangles, though? What did I draw? I drew a, starts with a D, not dot. Diagonal. Diagonal. I can start anywhere. I don't care where I start. Okay, where do you want to start? Evan said top on the last one, so we'll do the top on this one. Okay? So watch. I want to draw a diagonal. Do I draw it from there to there? No, it's got to go through it. So that would be 1, correct? Whoops. This would be 2. This would be 3. Okay, so I got 3 diagonals, but how many triangles did I make? Made 4. Let's mark them. So that's 1, whoops, that's 1 triangle, 2, 3, 4 triangles. So let's write this down. How many sides did I have? 6 sides. And you guys guessed on the last one, right? Right before I even drew this, you guessed about how many triangles we're going to have. It wasn't really a guess, though, was it? You kind of knew, right? You saw a pattern developing. You're like, you know what? It's probably going to follow on this one. So that would be 4 what? 4 triangles. So now, how do we find what all of these add up to be? Remember, this is 180, this is 180, that's 180, and this is 180. All right? You didn't really have to put that in there, but just so that you know what we're doing. So if you got 4 triangles, it's going to be what? 4 times 180. And that's, I believe, 720. Is that right? Okay. So, again, if I asked you, what are the sum of the angles of a hexagon? All right, what are you thinking? Hexagon means what? 6 sides. How many triangles am I going to get when I draw those diagonals? 4. How did I know I was going to get 4 triangles? Because the number of triangles so far has always been what? 2 less than the number of sides. Exactly right. Would you agree? All right. So every time so far, okay, you get the number of triangles is 2 less than the number of sides that you had. We good? Without drawing, watch this. Without drawing this thing, what if I had 10 sides? How many triangles? 8 triangles. And what's the sum of the angles? 8 times 180. And then that's, I don't know, again, I should have this. Is it 1440? I can't remember. 180 times 8. I was right, 1440. Okay? So if I had a 10-sided figure, which is a what? What do we call a 10-sided figure? Decagon. Very good. Deca. That's an easy one to remember. Decade. Remember that? All right, decade is 10 years. So a decagon, if I added up all 10 angles, boom, 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 all 10 of them, what are they going to add up to? 1440. Okay, 1,440 degrees. So you could do that with any polygon. All right? So here's what we're going to do. We're going to come up with a little formula. Remember, the number of triangles was what compared to the number of sides? 2 less than. 2 less than. Okay? So what we're going to do is we're going to come up with a formula that represents any number of sides. All right? Let's call that any number. Let's not call it x. Let's call it n for number. All right? So this represents what? The number of what? Sides. Okay? So we're going to go n. So what did we do to find how many triangles? We took the number of sides, and what did we do to it? Added. I took the number of sides, and I subtracted 2 to get the 8, right? So it's going to be n what? Minus 2. So that's how many triangles. The n minus 2 is how many triangles. Now, how did I figure out what all the angles added up to be? I took the number of triangles, and then I did what to it? Times it by 180. That's right. So watch. We're going to take this and multiply it by 180. That should make sense to you from what we just finished doing. Does it? N is the number of sides. N minus 2 is how many triangles that we had. And then you take how many triangles you had, multiply it by 180, and that's going to give you the sum of all the angles. Make sense? All right. So that is our formula. Let me get rid of some of this stuff and put it in a box. When it's in a box, you know it's important, right? All right, so we're going to put it in a box. There it is. So if you wanted to find the sum of the angles of any polygon, technically it's a convex polygon, all right? Doesn't work with a concave. Do you remember what a concave polygon was? Well, not, I mean, they still touch each other on a convex polygon. A concave would look something like this. Do you remember that? See, like if I extended that, it would go through it, right? And it would go through it. So this thing right here does not work with a concave. It only works with a what? Convex. That's why I titled this lesson Convex polygons. Everybody with me on that? Yeah, and we rarely deal with stuff like this anyway, so really that's really not going to come into play that much. Let me guess. It's your bathroom time again, right in the middle of my class. Is that when your body tells you have to go to the bathroom? It'd be nice if you went before this class. It really would. No, you wouldn't. I've left here. I've left as soon as the bell rang. I would go to the bathroom, right? And I'd come back and I'd be back before the bell rang, right?
But Miss Burns is long-winded, so that's like a couple more minutes.
I don't think so. All right. Look at all my signatures on that thing. I got like 90% of signatures on there. Get some other teachers to let you out. All right, enough of that. Here we go. So what if let's do one that we haven't done before. Don't go real big. Don't go like 1,000 sides or anything like that. Give me something 20. Okay, let's do 20. Now, we might need a calculator for this. But if I asked you, oops, why I put an S? I don't know why. 20 sides. Okay, what if I had 20 sides and I asked you to find the angle sum, the sum of the angles of a 20-sided, that doesn't even have a name, okay? It's so big. A 20-sided polygon. What if I asked you to find the angle sum of that? What would you do? Use this formula, n minus 2. So what's my n? Well, no, my n's not 18. My n's how many sides I have. My n is 20. So what do? I go 20 what? Minus 2, and then I take that and multiply it by 180. Okay, 20 minus 2 is 18, so it's just 18 times 180. And then you put it in a calculator, and whatever that is, I have no idea what that is. So I'm going to put it into a calculator. So 18 times 180, and that's 3240, okay? That's not even a number that I even recognize. But that's how many degrees. That's the angle, what? Sum. Okay, the angle sum is 3240. All right, we got that down. We got one more thing to talk about. Well, maybe. Two more things, actually. Yeah, I got time. All right, let's do this. What if, I'm going to come over here. I like this program I use because this will give me a polygon. But it's not just, remember before I was just doing random polygons, just a random quadrilateral, a random pentagon, a random hexagon, yes? Yeah, it was nothing special about them, right? But there's definitely something special about this. What do you think is special about this one? How many sides does it have, by the way? 1, 2, 3, 4, 5, 6. 6 sides. So this is a what? Hexagon. Let's write it right here. Hexagon. But it's a little more special than the hexagon I drew earlier. It's not just a random hexagon. What do you look at it? What do you think might be true about this hexagon that's not true about that random looking hexagon that I drew earlier? It's equilateral. I heard somebody say that. Who said that? Good. Io? Donnell? Okay, so it's equilateral. So that means all what? All the sides are equal. That's true. What else do you think might be true about this? Okay, it's convex. Okay, all the ones we're going to deal with are convex. So that's not really what we're talking about. Look at it. What other thing? There's sides and there's what? Angles. Look at the angles. Look at this angle and this one and this one and this one, this one, this one. They're all the same. They're all exactly the same. Now that's really important for what we're going to do right now. So what we're going to do right now, we're not just finding the sum of all the angles. We already did that earlier. Guess what we're going to do now? We're going to find, anybody still with me? I got 1, 2, 3 right there. Well, 1 popped up. 2 are still down. Okay, 1's out for a count. Nope, you're up. Okay. So let's think about what we're going to do right now. Do I have any place further away that I could put him? Maybe up in the ceiling, maybe? So watch. This is a hexagon. All the angles are equal to each other. So guess what I'm going to do? I put an angle. I put an arrow right here. What do you think I'm going to do? Find each angle. Right. Not all of them together, but I want to find each angle. Now, since they're all equal, each angle is going to have the same value, correct? All right. For instance, if I had not doing this, so don't get excited. But if I had $100, right, and I picked out 5 of you, now let's say 10. I picked out 10 of you, right, and I wanted to give each of you the same amount of money. So what'd you do? You went 100, divided it by 10, correct? Would you agree with that? Okay, so watch what we're going to do here. Since all these angles are exactly the same, I want to find out what all the angles add up to be. We already did it earlier. Let's do it again. How do we do it? It's a hexagon, so we go what? 6 minus 2 times 180. 6 minus 2 is 4 times 180. I think that was the 720, wasn't it? Okay. Does that mean this angle is 720 degrees? Does that mean this angle is 720? No. It means they all add up to 720 degrees. Everybody listen. They all add up to 720 degrees, but I want to find out, it's like I had, let's change the number from $100. Let's say I had $720, and I was going to evenly spread it out between 6 people, okay? My 6 favorite students, okay? I'm going to take $720, and I'm going to distribute it evenly amongst you 6, okay? And you don't know who my favorite ones are. You're all my favorites, by the way. Okay? So what would I do? What math would I do divided by 6? Okay, it's the same thing, isn't it? All of these angles add up to 720. I want to split it evenly, okay, among how many angles? How many angles do I have? 3, 4, 5, 6, right? So I go 720 divided by 6, which is what? Do you know what 72 divided by 6 is? It's 12, right? You stick a 0 on the end. So each of these angles is how many degrees? It's 120 degrees. I'm not going to do it for all of these, but you get it. So every single angle, each angle, that's what they're asking you to find. They're asking you to find each. Everybody see this? Not everybody is. Okay, and you're not going to have any clue, all right, what to do on this quiz, because I'm going to ask you a question just like this. It may be a hexagon, it may be another figure, but you do it exactly the same way. I'm finding each. This is not angle sum. This right here, what's the 720? The 720 is the what? Is the angle sum. Okay, what is the 120? It's each angle. Each angle is 120 degrees. All right? Now, this only works when what's true about all the angles? They're all equal to each other. Now, let me give you a word. I don't know if I've given this to you in the past or not. If not, so the first time, if I did, it's not the first time. We call this a regular polygon. I don't know if I used that phrase before or not. What does it mean to be regular? All the sides are what? Equal, and all the angles are what? Equal. So regular means you have the same sides. Let's not put same. Let's put equal. So equal sides and what? Equal angles. Okay? That's what it means to be regular. So this thing that we did right here only works when you have a what? A regular polygon. You with me? When I did those random ones, there's no way in the world that I could figure out what each of those angles were. But I could figure out what they all added up to be. This one, I can figure out what each angle is. Make sense? Let's do a figure that we haven't talked about yet today, an octagon. What if I asked you to find each angle of a regular, I should say this, let's throw this word in here, interior, because we're going to talk about, in a minute here, we're going to talk about an exterior, okay? But each interior angle of a regular, what I say, octagon. It's really not that hard. So hopefully you're taking notes. Are you taking notes? First thing I'm going to do is find out what they all add up to be first. It's an octagon. How many sides does an octagon have? 8 sides. Okay? So let's figure out first what they all add up to be, and then I can figure out what each of them are, okay? So let's do the angle sum first. How do I do the angle sum? 8 what? Minus 2 times 180. That's 6 times 180. I should know this one. Is that 1080? 6 times 180. Should have these memorized. Yeah, that was right. 1080. Why did I doubt myself? I don't know. 1080. Now, is that what they're asking? No. They're asking for what? For each of the angles. Now, all of these angles add up to 1080, correct? I want to find each of those 8 angles. So what do? Divide it by 8, right? Not by 6. A lot of people make that mistake. Okay, there's not 6 sides in an octagon. How many angles? How many sides? There's 8. So 1080 divided by 8. I'm pretty sure I remember this one. I think it's 135. Yep, it's 135. So if you had a stop sign, why do I say stop sign? Because it's got 8 sides, and it's a regular. A stop sign is a regular octagon. It means all the sides are equal, all the angles are equal. If you stopped, don't do this, but if you stopped alongside the road and you had a protractor, you know what a protractor is? It shows the angles, and you put it up against the angle, you'll see that each angle of a stop sign is how many degrees? 135 degrees, okay? Because it's a regular octagon. All right, let's do one more thing. What if I had this? Let's just draw a triangle right now. I hope you guys are still watching. I'm just going to, it's not any kind of special triangle, but watch what I'm going to do. I'm going to extend this side. Yeah, let's say I did make it special. Let's say I made that, and that equal to each other, okay? Did that for a reason. Oops. All right, come on. I got a couple minutes. I got to finish this. Look what I'm doing. I'm taking each of those sides and I'm extending it. So each of these angles in here, I wrote that down in the last problem. What are they? They're what kind of angles that are inside the triangle? They're interior angles. What about these angles that are outside the triangle? They're exterior. Okay, now watch. Listen. If all these sides are equal and if all these angles are equal, it's 180 divided by what? 3. So what's this angle right here? 60, 60, and 60. You with me? Now, what's this exterior angle going to be? If this is 60, what's this angle right here? Is it 180? That's an obtuse angle. What is it? 112? 120. How'd you get 120? You guessed? Look, you shouldn't have to guess. Let's see why. Zion just did the math wrong in his head, or he just said it wrong. Okay, but watch. That whole thing's 180, isn't it? Okay, so if that's 60, what's that? That's 120. Okay, because 180 minus 60. So what's this angle right here going to be? 120. What's this angle down here going to be? 120. I want you to see something. All right, I got a couple minutes, so hang on. Okay, what is the sum of the exterior, not interior, but exterior angles? It's 360. That's right. Because 120 and 120 and 120 is what? 360. Now, does that only work with a triangle? Nope. Watch this. Let's just do a rectangle. No, I'm not even going to do that. I'm running out of time. I'll just say this. It does not matter what kind of polygon you have. You could have a triangle, a quadrilateral, a pentagon, a hexagon, an octagon, a decagon, a hundredgon. It doesn't matter. Everybody listen. Don't pack up. Listen. Listen to me. It doesn't matter what kind of polygon you have. I'm going to put this in a box. Why? That's right. It's important. Okay, look. The sum of any polygon. It doesn't matter. If you find the exterior angles will always equal what? 360. So what's the sum of the exterior angles of a octagon? 360. What's the sum of the angles of a decagon? 360. You get it? It does not matter what shape you have, or how many sides you have, I should say. The sum of the exterior angles of any convex polygon is always 360, no matter what. Okay? All right. So now, your homework. Now, since I only gave you the 13 yesterday, I'm going to have to change it up a little bit. So if you look at your lesson plan that I gave you, it may not have these numbers. It won't have these numbers. So would you go through 14, right? So you're going to go 14 to 34. And it's section 61B. There it is. 61B, it's 14. If you look at the lesson plans, it's going to say 19. Okay? But remember, we stopped at 13 yesterday. All right? So you're doing 14 to 34. Okay? That is your homework right there.